For today's lesson, our focus standard continues to be from grade 8, Functions, Standard A, Define, Evaluate, and Compare Functions. Our topic is Mathematical Models, Comparing Views, Graphs to Equations. Our essential question is, how do we compare functions expressed in different views? So this was our essential question in the last video when we compared graphs to tables, and we're using it again today to compare graphs to equations, and we'll use it in the next video, comparing equations to tables. So let's go ahead and dive into today's problem. Today we're looking at two women, Isabella and Ingrid, who are both taking a botany class in college. They both have been growing plants for a class project, and they want to compare their data. Isabella currently just has a graph made of her data, so it is here, while Ingrid wrote an equation to model her plant's progress. And they want to compare and know the following. So we're going to ask really similar questions as when we did in the video, but take a few moments to study both Ingrid's equation for her plant's progress and the graph that Isabella would have made for hers. So while we don't quite know a whole lot, and we know that we should recognize this formula as being the slope-intercept form, y equals 3x plus 2.5, so we should be able to start to glean some information about Ingrid's plant. How tall was it when it started? How fast was it growing? With Isabella's, we know more about what her x and y mean because it's on a graph and it's labeled, and Ingrid right now does not have her variables defined, and she should. So on the x-axis, we have the number of weeks, and we're going to have to make an assumption that Ingrid is using x to represent the number of weeks as well. And on the y-axis, we have the height of the plant in inches, so we will assume that the y means the same for Ingrid's. And then we can see that it looks like a scale of 1 again, although the main grid lines are 5. There's little smaller lines inside of there. Looks like an x scale of 1. And it looks like the main grid lines are 20, 40, 60, 80, 100 on Isabella's graph. And there's 4 smaller grid lines. I'll zoom in on this in a minute. That are going up by, there are 4, so it must be going by 5. So 5, 10, 15, 20, and then so on and so forth. Alright, so always a good idea when given data in a graph or an equation or a table to really examine it before you try and dive too much in to make sure that you're reading everything correctly, and then make sense of that before answering the questions. So let's go ahead and begin now. So they want to know, first thing they want to know is whose plant was the tallest at the start of the project. So again, if we're talking about at the start of the project, this question is asking you to find the starting value. And what is another word, or how else do we talk about starting value? Well, we also talk about it as being a y-intercept. So go ahead and see if from this information, from the equation for Ingrid and the graph for Isabella, can you find how tall their plants were at the start of the project? So for Ingrid, looking here at that B value, hers is going to be 2.5 inches. And the starting height for Isabella's plant, if you look here at the graph, it looks like it goes right through the origin, 0, 0. So her plant started at 0 inches tall. So Ingrid got something that already had a little bit of a growth to it, 2.5 inches, whereas Isabella's plant had not broken through the surface yet. So at the start of the project, Ingrid's plant was taller. So now let's see, they want to say, okay, well, that gives us the starting value. Whose plant is growing the fastest, right? This is another good thing to compare. So now they want to know whose plant is growing the most each week. So we need to find the rate of growth, or the growth rate, for Ingrid's plant. So that's finding her M value from her equation. And then we want to find the rate of growth for Isabella's plant. And that's going to be a matter of using the graph up here to find that slope. So let's go ahead and do that. So from Ingrid's, you should be able to find that information from her equation. And for Isabella's, it might be a little bit better if we zoom in here. So hopefully we can see that a little bit better here. So now that we're zoomed in, you can see we have those grid lines 1, 2, 3, 4, 5. So we got a scale of 1 on the x-axis, went up to 20 with 4 grid lines, so 5, 10, 15, 20, 25, 30, 35, 40, so that holds up. So a scale of 5 on the y-axis. And to find the rate of change, we need to find a slope triangle. Remember, to do that, you need to use at least 2 points. Doesn't matter. I usually like to try and find the 2 consecutive, meaning the 2 closest points together. But go ahead and do your work and let's compare. So it looks like it's going through as far as finding 2 consecutive points. I started at the b value at the y-intercept because that was an easy point to read, 0, 0. And then it looked like it went through the very next grid line intersection at 1, 5. So that means it would have gone up by 5 here because the y-axis has a scale of 5. We can put that in. And the x changed by 1 because the scale on the x-axis was 1. It's always a good idea to label those things. So the y was increasing by 5 and the x was increasing by 1. And then from Ingrid's, we're looking to see, well, where is it over here? What is her rate of change? And if we're using slope-intercept form, this right here is going to be our m value. All right, so let's go ahead and fill in what we found. So for the slope for Ingrid's, we had seen her m value from her equation was 3. So we want to be able to fill that in a way that makes sense. So I just wrote m equals 3, but we want to remember that that represents the change in y over the change in x. And so the 3, that whole number, is going to be our change in y, because we can just then put a 1 in the denominator, and 3 divided by 1 still equals 3. So that means our change in y is 3, and our change in x is 1. So Ingrid's plant grows 3 inches each week. The rate of growth that we found for Isabella's, when we said, well, it was increasing, the change in y was 5, and the change in x was 1. So we fill that in, we simplify that, and we get 5. You might have gotten, if you used different points spread further apart, for example, we could have used the starting value and then this point right here, we would have said, oh, well, it goes up 20 and over 4. Well, notice that 20 over 4 would also reduce to 5. So we always want the slope in the simplest form. And so we should be able to all come up with something that is equivalent to 5 from our slope triangle up here. And so that tells us that Isabella's plant grows 5 inches each week. So whose plant is growing the most? Well, Bella's is growing 5 inches, so Isabella's plant is growing faster. And for our final question, then, we want to say, well, whose plant is going to be the tallest in 20 weeks? And so we already have Ingrid's in an equation, and so we can easily, we're using weeks here, so we could, since x represents weeks, we can plug 20 in. For Isabella's, we might need to do a little bit more work, and we need to use this information from the first 2 questions to write her equation and then do some calculations. So why don't you go ahead and try and do that for both of them. Pause the video here. When you're ready to resume your work, or if you get a little bit stuck, feel free to resume and we'll check in. So for Isabella's equation, I just used the m and the b value from up above, and I have y equals 5x. So some of you might have written plus 0 here, because the b value is 0. But one thing we have to ask ourselves is, does adding on 0 or even subtracting 0, is that going to change the outcome at all? And the answer is no. Adding 0 is not going to change anything, and so we don't write it in. And by not having a b value hanging off here in this y equals mx plus b equation, we know that the y-intercept must be 0. And So Isabella's equation is y equals 5x. Then for both of these, we wanted to plug in 20 and do our calculations. So I've done that here. I plugged in 20 weeks. 3 times 20 is 60, and then we're adding on 2.5 for that starting value. And Ingrid's plant will be 62.5 inches in 20 weeks. For Isabella's, if we plug in 20 into our equation, we get 5 times 20. Well, 5 times 20 is 100. So Isabella's plant, after doing our calculations here, we see will be 100 inches in 20 weeks. And so in 20 weeks, whose plant was the tallest? That would have been Isabella's. So yet another example of how do we use slope and y-intercept to compare, and looking at all the different views. And one of the things I hope you're seeing is that to be really exact, although we might be able to see it on the graph, some graphs are going to give us a value. Like if we, well, in this one we don't have necessarily a good example, but if I had asked in 10.5 weeks, how tall is the plant? Well, that would have been a really difficult question to answer precisely. And so we want to make sure that we're using our equations when we're asked for a really precise answer to show those calculations. And then if we want to compare it to our graphs, like here we could, follow up 20 on 20 weeks, we see it's 100, and so it shows us if we can see it in 2 different views, we know our work is accurate. So that's going to conclude our video for today. Please make sure that your notes are complete, and then be ready to discuss it more in class.